Hey guys, Mr. Bowman here. Our learning objective is in green today, and we are learning to calculate the mean in inverse Poisson distribution questions. Before we get into the question, let's quickly recap on what the formula is. So hopefully we'll remember the Poisson distribution. So the probability of random variable x occurring x amount of times is equal to lambda to the power of x times e to the power of negative lambda. That is then going to be divided by x, or the factorial of x. And the key thing to note was, in here, there are actually only two variables of interest. The first variable was x, and that's the number of successes. And the second variable was lambda, and that's the mean or the average number of successes. So the mean or the average. And very similar to like binomial distribution, our inverse questions only work when x is equal to 0. If x does not equal 0, then it will not work. And what we'll do is we'll find out that lambda to the power of 0 times e to the negative lambda divided by 0, the factorial of 0. Well, lambda to the power of 0 is 1, and the factorial of 0 is also 1. So you'll find that and that strips away, which means in inverse Poisson questions, the probability is equals to e to the power of negative lambda. So it does mean the formula actually is quite straightforward. So let's get into a question and let's see how we go. So we'll switch to yellow. Question 1. So I've got a picture of some fairy lights or some Christmas tree lights. And when I did a bit of research, I found out that these cables were produced in 100-meter lengths. So 100-meter lengths of fairy lights. And based on the scenario that we're interested in, we also found out, so we'll put a bullet point there, our next bullet point, we also found out that the probability of no faults within that 100-meter stretch, probability of no faults over 100 meters of fairy lights. And we were told that was 0.1496. So we've got our variables and we've got our description, and we just want to remember we only really need two variables to make this work. We need x and lambda. So if we have a think about this, so we've already got the probability of no faults. So the probability of x being equal to 0 is equal to 0.1496. We've been told that x will be equal to 0. And that there is enough information to figure out lambda. So if you have a look at the formula that we finished up down here, so we know that the probability of x being equal to 0, we'll go through the full formula, but that's going to be equal to lambda to the power of 0 times e to the negative lambda divided by 0 exclamation mark, or the factorial. Those cancel each other out. So that's going to become 0.1496. That's going to be equal to e to the power of negative lambda. And at this point here, we'll be able to use our graphics calculator to solve this function here. So do look in the description below or watch the graphics calculator video for how to use that. And when we put that into our graphics calculator, our lambda was 1.8998. And that there was rounded to 4 dp. So what that means is, if I produce a 200-meter string of fairy lights, on average, there is about 1.9 faults per 100 meters produced. So what we've done is we've inversely worked backwards. So we had the probability and we had x, and we worked backwards to find out what the lambda is, or the average. So if you haven't got that example down, please do. I'm going to pause the video. I'm going to clear our working and we're going to get into our second example in relation to Poisson distributions and working backwards to find out the mean. Okay, we're back. Hopefully you got that previous example. Question number 2. We've now moved on to another manufacturer. So another company, they produce these fairy lights. And again, they produce fairy lights in 100-meter lengths. And they've told us that the probability of at least one fault is 0.8947. And that's all the information that we need to figure out the mean. And that's what we're trying to do here, is we're trying to calculate the average number of faults. Okay, so let's think of the variables that we have. Well, we've been given the probability of it being greater than 0. Which means the probability of it being exactly equal to 0, noting that we must have exactly equal to 0. Well, that's going to be 1 minus that probability. Oops, so Daisy's got the numbers the wrong way around. 947, and that means that probability is going to be 0.01053. So the probability of there being no faults in a 100-meter stretch is 0.1053. So just draw a line there, because we're just going to separate that information. And the other bit we do know is, well, we do know that x is going to be equal to 0. And with these two numbers, so with the big probability and x, we will be able to go through and calculate lambda, or the average. And hopefully you remember from the previous video that the probability of x being equal to 0, that is x to the negative, or e to the power of negative lambda. And that's because 0 cancelled out, so the factorial of 0 was 1. And lambda to the power of 0 was also equal to 1. So it did cancel those parts of the formula out, and it did make it a bit easier to deal with. So let's rub those out. Now let's get into our example, or let's finish it off rather. So the probability of x being equal to 0, well, we know that's 0.1053, and that's going to be equal e to the power of negative lambda. And at this stage here, we need to use our graphics calculator and the solver function to find out what lambda is. And that is, so lambda is equal to 2.25, and now it's rounded to 2 dp. So that means we've worked backwards. The average number of faults per 100 meters for this manufacturer was 2.25. And then just thinking about the two numbers, and I'm just comparing the answers that I got. So use the grey pen. So the first manufacturer had 1.9 faults per 100 meters, and that was compared with 2.25 faults per litre. So that probably means that first manufacturer is doing a better job than the second one, because the average number of faults is a lot lower. So hopefully you found this video useful. I just want to highlight and emphasize, when you're using or calculating inverse Poisson questions, it is relatively straightforward. We've got our formula up here. All we need is the big probability of there being no successes, or x equals 0. And from that, we'll be able to use our graphics calculator to help sort out the lambda or find the mean. Okay, let's get into heaps of questions, and make sure you got this example down to assist you in the future.